A joule is a unit of energy or work. A calorie is the energy needed to raise the temperature of 1 gram of water to 1 Celsius.
The different types of energy are thermal, kinetic, electrical, potential, and nuclear energy. Thermal energy is a random vibration of atoms and molecules. This can be represented by the fire. Kinetic energy is energy a body possesses by virtue of being in motion. This can be represented by a ball going down a hill. Electrical energy is energy associated with the flow of electrons, which can be represented by the lightning. Potential energy is energy available by virtue of an object's position, which can be represented by a ball being on top of the hill, but it's not moving, which is important. And finally, nuclear energy is energy stored within the collection of neutrons and protons in the atom. This can be represented by the positive and negative charges in the nucleus of the atom and the nuclear explosion.
Basically, the particles of the pan are colliding with the particles in the handle, and since the particles in the pan are heated, there's a transfer of energy between the particles in the pan and in the handle, causing the handle become hotter.
Alright, for number 4, we have 3 different systems: an open system, a closed system, and an isolated system. An open system is a system where energy and mass can be transferred between the system and its surroundings. An example of an open system would be a glass with water in it, because water can escape the glass and energy can be transferred throughout the glass. In a closed system, energy can be transferred from the system and surroundings, but mass cannot be. An example of a closed system would be a pot with a lid on it, because heat can escape that pot, but no mass is able to. In an isolated system, no energy or mass can escape. An example of this would be a crucible with a lid on it, where energy is contained within the crucible and mass is also unable to escape.
Here we have two types of processes, one being endothermic and the other being exothermic. In the exothermic process, we have the system, which is the fireplace, giving heat to the surroundings, which is the steak. In the endothermic process, we have the surroundings giving in heat to the system.
Different substances can have different heat capacities because the space between the particles varies for each substance. For example, ice has a low heat capacity as the particles are closer together and transfer heat easier, while a cooking glove has a higher heat capacity since the particles are more spread out, causing the transfer of heat to be tougher.
The formula is Q equals M times C times delta T. The Q stands for the amount of heat, the M stands for mass, the C stands for the specific heat capacity, and delta T stands for the final temp. In this problem, the Q equals 13,794 joules, the M or mass stands for 100 grams, the specific heat capacity or C stands for 4.18 J over GC, which if you add all this up together to find delta T, it is equal to 33 Celsius.
Okay, for problem 8, we have this problem where we're going to be starting with 500 joules, 5 grams, and 10 degrees Celsius. We're trying to find how much specific heat is necessary to lower that temperature to 8 degrees Celsius. We'll start with the equation Q equals M times C times delta T, and through algebraic processes, we can find that C equals Q over M times delta T. After plugging in the variables, we get the answer 50 joules per grams times Celsius.